Okay, so I'm going to repeat this. I'm going to get, so we have this data here. It should be rectangular, so I'm going to delete, well, sorry. So we're starting with this file here, and then I want the data to be rectangular. So there's some stuff at the bottom, so I'm going to just delete it. And then here, do the same thing here just to make sure there's no stray data in there. Okay, so maybe it's clean. Now, since you were only working with supply and occupancy, I'm going to delete the other stuff and recreate your file. So, but as we said, we're not sure why Weka was treating your supply as nominal, which is kind of weird. And I'm just going to move these in the opposite order because I think what you want is you want to predict occupancy, right?
Yeah.
So in that case, it probably won't. It doesn't make that much difference, but it probably makes more sense to have it on the right-hand side. Doesn't really matter, but makes it a little bit easier. Okay, and now I'm going to save this as also a CSV file, but I'm going to call it supply and occupancy. Okay. Okay, and then I'm going to try and open it up in Weka and see if it treats it as, and usually Weka doesn't like it if you have it open somewhere else, or it might not like it. So I am going to open up Weka if I can. I thought I opened it up. I don't know what happened. Oh, here it is. Okay. And then I'm going to try and open your file. And see what happens. Okay, so supply is nominal. So that's weird, because it's not nominal, right?
It is.
But it's treating it as nominal. Occupancy is numeric. So, now there might be a way to convert nominal there might be here a way to convert nominal to numeric, but it sounds like a weird thing to do. We can look under attributes or instances. So I'm trying to work with changing an attribute from, an attribute means a variable, from nominal to numeric, but I don't see anything like that here. I see nominal to binary. That I don't want to do. And I can also look at what's under the unsupervised. Those differences are probably not clear to you. Honestly, they're not. It's not always clear to me, actually. But anyway, nominal, no. There's nothing like that. So that's not the way we need to do it. So we have to figure out instead why it's treating it, get it not to treat it nominally. So I don't know why it's treating it nominally, though. It really shouldn't. Now, there could be something in here if we scroll through it that's a mistake. But I don't see anything like that. First of all, this is too long, but that shouldn't make a difference really. But I'll just delete that. And one thing we could try and do is right click on it, go to Format, and change here Number. I don't know why this would make any difference, but we could try it. And save it. And then reopen it in Weka and see if it helps at all. It changed to numeric.
Oh. Yeah.
So I don't know, I can't tell you why that happened, but at least it worked. Okay?
Yeah.
So now at least we have supply as numeric, and occupancy is also numeric. So that makes sense that they should both be numeric. Now, like I said, when you click on one of these, then you can see that you've clicked on it here. It's called supply. You can see the type is numeric. I'm not sure. It means that there's 16 different distinct values, which is kind of weird because there's actually a lot of rows, right? There's 515 rows, but only 16 distinct values means that most of the values are, as you can see, they're all repeated here, right? But anyway, that's the way the data is. And this is also numeric, right? And this has 172 unique values. Okay? Pardon me. And okay. And then you can also get some statistics on each of these, like occupancy, we said is 28 is the minimum, the maximum is 94.8, the mean is here, and the standard deviation is there. And supply, you can also get data for that as well. Okay? Now, when you looked at the, well, now it's different. So this is the histogram for occupancy. So you can see that the lowest values are around 28.4. Can you see that?
Yes.
And you can see that the highest values are around 94.8. And this is the kind of picture of how the occupancy is distributed over our data set.
So what does that? What does the x-axis mean?
Sorry?
The x-axis.
Oh, what's this x-axis?
Yes.
So this is a histogram, and histogram is basically just a display of one variable. Okay? So if we click on occupancy, it's going to be a display of occupancy. If we click on another variable, it's going to be a display of that variable. So it's only a display of one variable, and then the heights are the frequencies. How many times was occupancy in this range? 75 times. How many times was it in this range? 97 times, 95 times. Do you understand?
So simply said, what do these mean?
Sorry?
Like for an example, if occupancy is 61, then no.
Remember, occupancy means what?
How many rooms?
Yeah, what percent of the rooms were filled, right? Right? So this means 61%. There were 75 days, right?
75 days.
Yeah, this means 75. This is the frequency means the number of days. So in our data set, there were 75 days when the occupancy was in this range.
So this has nothing to do with supply.
Has nothing to do with supply.
Yeah,
Okay?
yes.
Yeah, as I said, it's just, when you do a histogram, it's just a display for one variable, for a single variable. Okay?
Yes.
So the point of this picture is to show us, like, we can guess that the mean occupancy was around this range here, right? That's basically the center of this picture, right? Is here. So what is this? This is like, here, if I put my mouse here, it says between 64 and 70, right? You see that?
Yeah, I do.
So that means the average occupancy might be between 64 and 70. But we know what the average occupancy was, actually. It's right here. It's 65, right? The mean, right?
The mean is the one that's there most frequently.
The mean means the average.
Okay.
Okay? So I'm saying the average occupancy was what? 65, right? And that's what this picture also shows. This is just tells me what percent of the time was it in this range, what percent of the time was it in this range, what percent of the time was the occupancy in this range, how much of the time was it all the way up here at 94%. I'm sorry, yeah, 94%. You know what I'm saying? You sure?
I think so.
Just,
Distribution.
yeah, just a distribution, that's all. That's all, yeah, that's all it is. Okay? All right. So you can do the same thing with supply. You can see it looks like this. So supply, a lot of the time it was down here. Now what does supply mean, by the way?
The number of rooms.
The number of rooms, okay. So there were some of the records, many of the records, the supply was in this range. Not too many of the records had supply in this range. More of the records had supply in this range, right? You understand? Okay, now, so that's this is a histogram for the supply data, for the supply variable. Okay?
So
It's just a distribution. It shows us the distribution. So I don't know what supply really, I don't know how to, supply doesn't mean very much to me. I don't know. Maybe it means something to you. What does it mean to you?
like in general?
Well, in this, I mean, when we're talking about hotels.
How many rooms?
Yeah, how many rooms?
You know, hotels in Philadelphia
Okay.
available for customers.
Right. So why does it change? I wonder, why does it change over time? Why does it change?
Because some hotels, maybe, I don't know, either they're cleaning those
okay.
or some hotels closed or
Right,
some
right.
rooms
Or maybe, yeah, right. Is this an increasing sequence? 45. Oh, it looks like it's increasing. So that means that maybe they're building new I'm sorry. Oh, yeah, Maybe they're adding new rooms to the hotels.
That would make sense.
Yeah, because it's kind of, I think it's increasing. Anyway, so actually let's make a graph of that. I want to see what it looks like. And you could do this also to include this in your report. You could but let me just do it right now. So I'll do insert graph. Yeah, it's increasing. Oh no, it's decreases here. Anyway, that's kind of interesting, right?
Line, okay. I got it.
Yeah.
Yeah.
So it's kind of increasing, except for one place here it decreases, right? It decreases here, but I don't know why that was. But basically, the supply is increasing. Okay. Anyway, so going back to here. Okay. So now, so we solved a big problem here, and that was we got supply to be numeric. Now I'm not sure why it worked, and I'm not sure if it will even work again. If you do it at home, I'm not sure it will work because I don't know why it worked. But hopefully it will work. Okay?
Yes.
All right, now you can go to, there's really not too much you would want to do with these filters. If we look at them, they're broken up into attribute and instance. So attribute means if you want to do something on a column basis, because attribute means variable. So if you want to work on a column basis, that would be attribute basis. And if you want to work per row, if there's something you want to do on a record basis, then that would be per instance, because instance means record. Okay, so, but still, even if you think about it that way, it's not always clear why they've divided them up into instances versus attributes, but that's the way they've done it. Stratified remove folds, I don't even know what that means. And here, I mean, there are a lot of interesting things they have here. Like you can add noise, which sounds like a weird thing to do, but you could kind of, you know, add in some randomness to your data, which sounds like a weird thing to do, but I don't know, maybe under some circumstances you might want to do that for like testing, or I'm not sure. All right, anyway. But anyway, there's not that much we'll do there, so we go directly to the classify. And this is where you do the data mining. This is where you do the modeling. So you want to predict, first thing you have to do is tell Weka which is the variable you're trying to predict. And that's done here. You select the variable here, that's the one that you want to predict. So we want to predict occupancy, so we'll leave it like that. I'll send you this video. Okay? But I'm not sure the sound is working, but try it. And then here, remember we can use a percentage split, or we can do cross-validation, and so on. Now, let's just use percentage split. That means we're splitting between our, what do you remember what that means?
The testing
Right,
set
that's
and
right.
Modeling set.
That's right, yeah. One is the training set, or as you said, the modeling set, and the other is the testing set. So here it defaults to 66% for the training set, or the modeling set. So if you want to change that, you can. There's no real rule about what to do there. Okay, usually I do somewhere between 70 and 80% but there's no rule. Okay? Okay, so let's try it. And let's try something that we've already studied. So let's try a neural network, which in Weka is called a multi-layer perceptron, and it's under the functions category.
And click start.
Right. Yeah, then click start, and it's finished.
I go to this form. Mine shows 174. I think it's because it deleted something.
Okay, maybe. I'm not sure.
Maybe I have a different file.
Maybe you have a different what? File?
File.
Yeah.
Yes.
Okay. But unfortunately, it's not too good. The results are not really what I would call good. Although, one thing is that maybe I made a mistake. Well, we get this correlation coefficient is only 0.7. That's pretty weak. We'd like to get something close to 1, like 98% or something like that, but we got very, very low. Now the other thing is, let's try one more. Let's go to linear regression. Let's try that, linear regression.
Yes.
And let's try that one. And now it's even worse. So we're getting like nothing here. We're getting like no predictability here between supply and occupancy. Okay?
Mm-hmm.
So that doesn't make us particularly happy, right? Right. But that's what we're getting. So you can report that, of course, and that's it's important to say that. And I want to try one more here. There's something called where is it? It's called rules. No? 0R. Just curious. Yeah. Anyway, it's very not good. Okay. All right. Now, let's do something else. And that is, I think I mentioned this in the video. Maybe I didn't, but I think I did. Let's change occupancy into a categorical variable. Do you remember? I think we did. Didn't I do that in the video or not? I don't remember, honestly.
Was it the one with the add in or something?
It's when I used if.
If?
Equal if then.
Something really long that I didn't.
Yeah, very messy. All right, let's go through that. But I wonder if there's any way to do it here. How can we do it here, I wonder? So we'd want to change, I'm not sure, change discretize. Ooh, this might be it here. Maybe we can do this with Weka without that if-then. Let's see. Oh, but I wanted to discretize this one. So now I click on this. Oh, it's going to work. Okay, let's try that. Let me see what happens. And then I'll explain it afterwards. How do I run it? Here. Okay. So what I did just now, I ran the discretize filter, right? You saw me do it, right?
Yeah.
The way that I did it was I chose it here under discretize, right? And then I made sure that I had wait a second. Oh, I did it on the wrong variable. I made a mistake. I did it on supply. Okay, I didn't mean to do it on supply. I wanted to do it on occupancy. I wanted to do it on the variable I'm trying to predict. Okay, which is occupancy, right? What I'm trying to do is some algorithms work with work for predicting numeric data, and other algorithms work for predicting non-numeric data. So tree algorithms work better with non-numeric data. And I think we talked about, I'm talking about the variable we're trying to predict, the output variable, can be nominal or can be numeric, right? Right? The output variable, obviously, all variables can be numeric or nominal, right? They can be numbers or they cannot be numbers, right? Obviously, right? It could be a numeric data, or it could be like your favorite beer. That's not numeric, right? Right? So each variable could be like that. And some algorithms work better with non-numeric, and some algorithms work better with numeric. So if I can make occupancy, which I already said was numeric, if I can make it into non-numeric, if I can make it into categorical variable or qualitative variable, then I can use different algorithms on it. Now in the video before, I think I used the if-then. So I did it like this. I said like this. I wrote equals if, right? Can you see that or not?
Okay.
And then open bracket, and then I want to say if B2 is greater than, let's say 95% or 95, then I'm going to give it a category. I'm going to give it a name. I'll call it like A. Doesn't matter whatever I call it. It's just a symbol. Do you understand?
Yeah.
And then I could put comma B. So that would mean if it's greater than 95, I'll call it A, and otherwise I'll call it B. You understand?
If it's bigger, it's A. If it's different, it's B.
Right. Okay? All right, so if I do that, then this one is B, right?
Yeah.
Because this was not bigger than 95, right? And if I copy this down, most of them are going to be B, and a few of them are going to be A, I guess. I don't know which ones they look like they're all B. So they're all less than 95, but I know that some of them were actually greater than 95, so there should be some A's here. But there weren't many, right? I don't even see any, but I know that there must be some A's. Yeah. So there must be some A's, but that's not enough categories. I want more categories than that. Okay? So I'm going to change this. I'm going to put another if statement in here. So it's going to say if it's greater than 95, then A. Otherwise, and then I'm going to put otherwise if the same cell is greater than 90, then I'll call it B, and otherwise I'll call it C. You understand?
Mm-hmm.
But then that's even not enough categories. I want to have more categories. Okay? So I can put another if in here. Instead of C, I'll just say if again, the same cell is greater than 85, then I'll call it C, and otherwise I'll call it D. And I can keep doing this, right? And I have to make sure I have the right number of parentheses, otherwise Excel will complain, like that. Oops. Well, wait. What happened? Wait. Let's see. Oh, it kind of fixed it for me. Okay? Now, I guess it has the right number of parentheses now. Okay? Anyway, that's one way to do it. I can do it in Excel. But Weka has a way of doing it also. So Weka's way of doing it, this is called, in Weka they call it discretizing this occupancy variable. We're changing it from numbers to something like categories. Right? You understand? So that's called discretizing. And Weka does it for us. We don't have to write all that stuff. We use this. By the way, I did it on the wrong variable. I did it on supply. So let me undo that by going to undo here. Okay? I did it. I did it on supply. I meant to do it on occupancy. You can see supply is the variable that I discretized here. I don't want to do that, so I'm going to undo it. All right, now we're back to where we started. And now I'm going to make sure that I've selected occupancy, and I'm going to use this discretize function. And I do it over here, and I apply it. And now I've Wait. It didn't work. Oh, sorry. Let me try it again. Undo. Maybe I have to select it here, actually. I have to put the check mark in it. Okay? You see, I had to select the check mark. Well, let me try it now. What's going on? Not working. Ah. No, I don't know. Why is it not working? Let me undo it again. Oh. Here. I don't know. I have to tell it which attribute I want to do it on. Do I want to do it on the first one or the second one? So what's the answer? First or second one? What?
Second.
Yeah. So I need to put in 2 here. Let me try it now. No, it didn't work. Why? Let me undo it. Attribute to 10 bins, desired weight of instances. Ignore class. Invert selection. Make binary. Use bin numbers. Should work. But it's not working. Still numeric. Let's try more here. See, get an explanation. Yeah, supposed to work. Makes it into nominal. Except it says it skips the class attribute if set. Now our class attribute is Hmm. That's too bad. I would like to use this, but I don't know why it's not working. Hmm. Hmm. Well, it seems to work for doing it on attribute 1, right? Attribute 1 now is nominal, right?
Mm.
So maybe we can cheat and we can I don't know why it doesn't work. Such annoying. I think it's let me try this. I don't think that makes a difference, but nope.
Maybe it's in the data source.
Sorry?
Maybe it's in the data source.
What's that? Sorry?
Data source.
Data source?
Maybe the problem is in the data source.
Maybe. But it should work. Hmm. Let me try something else here. One more time. No, I don't know what's going on. So I stopped the video and now I'm recording it again, and I'm showing you how to use the experimenter. Now, as I said, I don't know if this video is actually working. The sound may not come through. But anyway, this thing called the experimenter looks like this. And what you have to do is click New first. I don't know why they make it like that, but you have to click New. And then you can start. And what you do is, over here you can add as many different data sets as you want. Now we have 3 data sets so far, right? I saved 3 different files. Wait, I think I had 3. Yeah, I have this one, and this one, right? Okay? You agree?
Yes.
Okay. So I can load all of those into this interface. So I just do Add New. Now, it usually prefers that there are files. Do you know how to make it into our file? Yeah, you do. You did it before, yeah. Okay, anyway, I'll just do it with CSV. Maybe it won't matter. And I'll do, which was the one we had first? Supply occupancy, so I'll put that in first. Doesn't matter. and then I'll do it again, and I'll do this one, and then I'll do it again, and I'll do this one. Okay, do you understand what I did?
Just adding the file.
I just added each of the data sets. Okay, now you can add in as many algorithms as you want, and it's just going to go through all of them, test all of them. So for example, you go to here and you choose the algorithm that you want. Now we worked with trees, so we worked with J48, so I'll try that one. So now I have, oops, why didn't that work? Go to J48. Where is it? Oh, trees. J48. This one? Yeah. Okay, and click OK. Okay, so I have 0R I'm testing. I'm testing J48. I'll test, I'll test, what other ones did we use? We used neural network, so I'll add that one in. So now I have neural network in there, and I can just keep doing this with lots of other ones as well, even though we didn't study them. We could do naive Bayes, which we're supposed to study soon. We could do, there's a lot of them. Obviously, there's many of them here. We could try, we don't even know what these are, but we could just try them and see how well they work. Okay, so I'll try this. So I'm going to go through all these 3 data sets, and I'm going to try each one of these algorithms on each data set. Okay? Watch. So what you have to do next in this interface is you have to decide, are you doing cross-validation, or are you going to do train test percentage split? So we've been doing train test percentage split 66, so I'll continue that. Right?
Cross-validation.
I don't want to talk about it right now. I think I talked about it in class. But anyway, let's just do it this way. So, and that's all you really have to worry about. Then you just go to Run, and you just click Start. And it's going to go through all the data sets and test each algorithm. Okay, ready? Okay, now it got interrupted, and it said class attribute is not nominal. Is that true? It
could be on like any file.
Sorry?
It could be on any file.
Yeah, that's one thing, is it could be on any file, but actually it's on all 3 files. Because these are the CSV files, right? So it's just, it doesn't know that I want them to be, I haven't made them nominal. So I have to do it this way instead. I have to go back to the other interface, here, go back to here. So this one was the supply OCL occupancy, right? So I have to go back and save that as an R file, right? Now, occupancy is nominal in that R file. Okay? Otherwise, it wasn't nominal, right? And these algorithms that I was testing just now, they're expecting nominal, and it's not nominal. It wasn't nominal, so it wouldn't work. Okay? So, okay, but this one is now nominal, but the other data sets are not. So I have to open up each one of them and do it. Okay, I'll do it just to show you. So let's see. This one was what was the first one? This one. And we have to go to here. No class, and we have to go to here. We have to change this back to 2. And then maybe this will work. This is still no class. Apply it. Yep, it worked. Then save this as an R file. And then do one more. This one. What was the next one? The one we haven't done yet was this one. Wait, no. This one. So now I have to make this one nominal as well. So I want a second attribute, and I want this to be no class, and apply, and okay, it worked. And save this one as an R file. So now I have this R file, and this R file, right? Okay, now I go back to that other interface, the experimenter interface. I have to delete these because these are mistakes. And I want to add in the R files, which are these. I wonder if I can select them all. Probably not. Yeah, I can. Okay, now I have those. Now let's see if it works. So go back to the Run tab and click Start. Okay, it seems to be running. Oh wait, I did the cross-validation by mistake, I think. So it's taking longer. But okay, let's just let it go. Okay. Oh, shoot. There was an error. The AD tree cannot handle multiple valued nominal class. Okay, so this AD tree doesn't like to have many, remember our output variable had 5 classes, right? And this tree doesn't like that, so I can't use that one here. So I have to get rid of this one. So let me get rid of that, delete it. And why was it taking so long? Okay, anyway. Let's try it again. Now this one may not like it either. I don't know. We'll see. Try it again. Down here it's telling me the number of times it's going through it, but I'm not quite sure why it's doing this. But anyway, let's see what happens. Okay, no errors, it finished. You see that? Mm-hmm. Okay, now we go over here, and now again you have to do a little stuff here. I don't know why they make it like this, but you have to click on Experiment, and then you have to decide which kind of result you want. So let's use the percent correct, just use this default one, and you have to click here, Perform Test. And we get the results. Okay, so the best result was only here, 41.61, right? That's the best result. So that's when we used Bayes, and we used this data set. Why didn't we get 45? Oh, because there's some reason it's doing an average. But I didn't tell it to do an average. Oh, here. It's doing number of repetitions are 10. I'm not sure about that. Let me try it again. Now it should go much faster. Okay, now it's done. Let's try it again. I think I have to click this again. And I have to click that again. Yeah, now we get that 45 in there. In fact, here we get 48. Okay, so you can see which one did best. This number 3, which is this one. So it was the neural network, and with which data set? This one, OCL predict OC. So we didn't use supply at all. Okay, so like you said, you said using supply makes the results worse, and you were right. Okay?
Mhm.
So the thing is, the reason why in the last one I didn't get that 45 or 48, like here, here, I didn't get such high numbers here, right?
Mhm.
The reason was because over here I had the number of repetitions set to 10, so I'm not really sure. Well, it's selecting different sets of data, different. So here it's selecting 66%, right?
Mhm.
But it chooses a different set of data each time and then averages the results. So somehow it didn't work out as well. Anyway, I can see you're getting tired there. um, all right, so I don't know if you want to use this interface or not. You don't have to. I just thought I'd show it to you. So we can, but anyway, I think you have some ideas here. So you can try some of this and see what you get. So far the best we've gotten is 45 or 48%. So you can think of other combinations of variables. So that was when we used yesterday's data to predict today. Okay?
Mhm.
Now, one thing is we used supply to predict occupancy, but you know, there's one problem is basically we should never use today's data to predict today.
Yeah.
So the input variable should always be lagged at least one day. So if you're going to use supply, even that should be lagged by one. I'm sure it won't make any difference, but I'm just saying in general, you should use. You shouldn't try and predict what's going to happen today based on today's data. So you should lag. No matter, every input variable should be lagged at least one day. Don't you agree?
What is that about?
Because, what good is it if I predict what's going to happen today based on today's data? That's useless. That means I need to know what's going to happen today before I can make a prediction about what's happening today. That's silly. Right? If you want to predict something, you don't want to predict what's going to happen today. You want to predict what's going to happen tomorrow today.
Mm-hmm.
Right? I can tell you.
There isn't any data that you could predict.
If suppose I tell you, okay, I can predict the stock market today, but I'm not going to do my prediction until 7 o'clock tonight.
Mm-hmm.
You're not going to be very impressed, right? If I say, okay, I'm going to tell you if IBM stock is going to go up today or not.
Yeah, it's only useful when there isn't any data, some kind of variable that we could, find out based
What?
on this.
What did you say?
If there is some information lost about today, and we want to predict it.
I don't follow you. What I'm
For
saying is,
example-
let me just finish what I was saying. So, I say I'm really smart. I can predict what's going to happen to IBM stock today. Right?
Mm.
I'm going to tell you whether it's going to go up or down today. Okay?
Mhm.
And then, I wait until 8 o'clock tonight, and then I tell you, okay, I predict that IBM stock went up today. That's not going to be very useful to you, right?
Not for stocks, but if there is some data that lacks something, and you want to predict the lack.
Can you give me an example? Because I don't follow you.
For example, if there is like one day, and we have all kinds of data, and we want to predict supply, but we don't have any data to predict supply, and we don't have any data.
Oh, you're
supply,
saying if we don't know, okay.
So we can just take the past data, today's data, and predict today's supply. Maybe.
So you're saying, okay, if we couldn't, for some reason, we can't know, in general, we can't find, okay, yeah, that's a good example. That's a good example. Sorry? Sorry?
I mean, Weka cannot do it because we have to delete the rows.
No, we don't have to. No, that's a good example. So you're saying if we don't know if we can't know today's occupancy rate today, but we can use some other tool to predict what it should be today, even though we can't really. Yeah, okay, that's good. Yeah, but I can't imagine exactly that why. Well, I don't know. Yeah, I understand that's a good idea actually, but it seems like in this case it doesn't really make sense for occupancy.
No, yeah.
Because why wouldn't we know today's occupancy today?
Well, there are certain reasons, but I don't think it's important.
Can you give me an example of why we wouldn't
For
know?
example, if there's some kind of an annual report,
Yeah.
and the data gets collected for days and only gets published a month later.
Yeah, maybe. Okay, anyway, you understand what I'm saying, right?
Yes.
Okay. So, I would say in general anyway, maybe there are cases where it's not true, but in general, we don't want to predict today's data with today's data. But if you want to justify some particular example where that would be useful, that's fine. If you want to write your paper that way, that's fine. But as a general rule, I would think you don't want to do that. But I'm sure that there are, like you said, there are cases where you might want to do it. So if you can justify it, that's fine. Okay, anyway, but other than that, I would say you don't want to use today's data to predict other parts of today's data, except for special cases. Okay?
Mm-hmm.
So be aware of that, and you can try and write your paper. And if you have more questions, we can do one more time, but I think that's enough for today.
I have just one question about how many of these algorithms do I have to use? Is it enough to just take one algorithm and...
It would be better if you did at least 5.
Wow.
Well, that's
It
easy.
would take me days.
What?
Maybe.
What do you mean? I just did 5 in 5 seconds, in about 5 minutes. Right?
And I mean, if I take all kinds of attributes...
I see. No, you don't. Well, first of all, you could do that quite easily with the experimenter interface, but I'm not asking you to do that. But you could easily, here I made 3 different data sets, so that's 3 different sets of 3 different sets of variable sets, right? The first one was the lag of occupancy to predict the lag of occupancy. The lag of occupancy to predict the occupancy. Second was supply and lagged occupancy to predict occupancy. So I have 3 different sets of variables and 5 different algorithms. That's already, I did 15 tests. But you don't have to do this. We didn't learn how to use this interface in class, so you don't have to. Anyway, so no, you don't have to do so many in that case. Just you can do just one if you want. If you're going to test many sets of variables, then you can just do one algorithm.
Mm-hmm.
Okay?
Mm-hmm.
Okay. Anything else?
No, I think it's okay.
What's that?
I think, yeah, it's okay with that. Mm-hmm.
Right. Okay, let me just, well, okay, so if this video works, I'll post it to YouTube, and I will send you the link.
Mm-hmm.
Okay?
Mm-hmm. Thank you.
Okay, if you need more help on it, let me know.
Mm-hmm.
We can do it maybe one more time. All right?
Okay.
Okay, good luck.
Okay, thank you.
Yeah, bye.